Right now, there's a plant growing in your garden. You have probably pulled it out a dozen times, called it a weed, maybe cursed at it for stinging your ankles. But that plant, the one you have been throwing in the compost bin for years, has been quietly sitting on top of one of the most thoroughly documented bodies of herbal medicine in the Western world. My name is Angus McGregor. I am 78 years old, and my family has used this plant for over 300 years. My grandmother kept it growing along the north wall of every house she ever lived in. She called it by its old Gaelic name. Modern researchers call it Urtica dioica. Everyone else calls it stinging nettle, and most of them want nothing to do with it. Here is what most people assume, that if something were genuinely powerful medicine, doctors would prescribe it, pharmaceutical companies would bottle it, and nobody would be pulling it out of the ground like a nuisance. But the truth runs in exactly the opposite direction. The plants that cannot be patented are the ones that stay in the garden. More than 200 published clinical studies now examine the pharmacological properties of Urtica dioica. I have spent the last 4 years reading them, cross-referencing the chemistry with what my grandmother actually did, and the overlap is extraordinary. These are the stories they never put in the brochure. Subscribe so you never miss what they forgot to tell you. But here is the question that none of those studies fully answer. Why does a plant this well-researched still get yanked from the ground by millions of people who have never once been told what it can actually do? That question will follow us through everything you're about to hear. And by the end, the answer is going to change the way you look at every untidy corner of your garden. Before we talk about what stinging nettle does inside the human body, you need to know exactly what you are looking for. Misidentification is the first mistake people make, and it matters. Urtica dioica. The stinging nettle is a perennial herbaceous plant. It dies back in winter and returns from the same root system every spring. The leaves are heart-shaped with deeply serrated edges, almost like a coarse saw blade. They grow in opposite pairs along a stem that is distinctly square in cross-section. That square stem is one of the most reliable identifying features. The plant reaches anywhere from 3 to 7 feet tall in good conditions, taller than most people expect from something they dismiss as a weed. The sting itself comes from tiny hollow hairs called trichomes, packed densely on the underside of leaves and along young stems. Each trichome is a miniature hypodermic needle made of silica. Touch it, and the tip snaps off, driving a cocktail of formic acid, histamine, and serotonin directly under your skin. That is the sharp, burning sensation you remember. It fades within 30 minutes. The plant will not harm you, but it will absolutely make sure you notice it. Stinging nettle grows almost everywhere in the northern hemisphere. It loves nitrogen-rich soil, which means you typically find it near compost heaps, along fence lines, beside old outbuildings, on riverbanks, and, critically, in the forgotten corners of otherwise tidy gardens. Where humans settle, stinging nettle follows. Urtica dioica has been recorded in medicinal use across Egypt, Greece, Rome, and Scotland for at least 6,000 years. That continuity across completely unconnected cultures is not coincidence. A single mature nettle leaf, analyzed by modern chromatography, carries more than 30 active compounds, vitamins A, C, K, and several B vitamins. Minerals including iron, calcium, magnesium, and silica, flavonoids, polyphenols, and a class of lectins that researchers are still characterizing fully. The plant you have been pulling from the ground is not empty, it is extraordinarily dense. Learning to recognize it properly is step one, because everything that follows depends on knowing you have the right plant in your hands. Here is the structural problem. The reason this plant stays in the margins, despite everything science has found about it. Drug development in the modern era runs on patent protection. A pharmaceutical company spends somewhere between $800 million and $2 billion bringing a new drug to market. The logic is brutal but clear. You spend that money only if you can own the molecule you develop, charge for it exclusively for 20 years, and recoup the investment. You cannot patent a plant that grows wild in 50 countries. You cannot patent Urtica dioica. It is not ownable. The Dietary Supplement, Health and Education Act, passed in 1994 in the United States, created a legal category that allowed herbal products to be sold without the clinical trial burden required of pharmaceuticals, but it also stripped them of the ability to make specific medical claims. The result is a strange limbo. The plant can be sold, but manufacturers cannot legally tell you what the research actually shows. So the research accumulates in journals that most people never read, while the plant itself keeps growing in your garden, completely unaware of the legal situation. Before 1850, stinging nettle appeared in every major European pharmacopoeia, the official reference books that doctors and apothecaries used. The British Herbal Pharmacopoeia, the German Commission e-monographs, and the European Medicines Agency's Herbal Monograph System all still carry formal assessments of Urtica dioica. The knowledge was never lost. It was reclassified. My grandmother did not know about patent law. She knew that the plant worked, for joint pain, for allergies, for the fatigue that comes in late winter when the body is depleted. She passed that knowledge to my mother, who passed it to me. The chain held because the plant itself never stopped growing. The villain in this story is not malice. It is economics. And the consequence is that several generations of people have been pulling their own medicine out of the ground and throwing it away. The area of research with the most robust clinical evidence involves inflammation, specifically the kind of slow, chronic inflammatory response that underlies osteoarthritis, rheumatoid arthritis, and joint pain in general. Here is the mechanism, as clearly as I can put it. Inflammation is not simply pain. It is a cascade of chemical signals in the body. One of the most important is a protein called TNF-alpha, tumor necrosis factor alpha. When TNF-alpha levels stay chronically elevated, tissue breaks down over time, joints swell, cartilage degrades. Most pharmaceutical anti-inflammatory drugs work by interfering with this cascade at various points. Urtica dioica leaf extract blocks a signaling protein called TNF-alpha and interrupts the NF-kB pathway, one of the central regulatory switches of the inflammatory response. This was demonstrated in laboratory settings beginning in the late 1990s, and the findings have been replicated multiple times. A clinical trial at the University of Plymouth, published in the Journal of the Royal Society of Medicine, took patients with osteoarthritis of the thumb or finger joints. One group received stewed nettle leaf applied directly to the affected joint for 1 week. The control group received dead nettle, visually similar but pharmacologically inert. The nettle group showed a 27% reduction in pain scores and a 25% reduction in disability scores compared to the control. That result held across the patient group with impressive consistency. My grandmother never applied stewed nettle to her joints. She drank it as a tea every morning from March through October. The method matters. And the difference between topical application and internal use produces different effects through different pathways, which takes us into territory that most of the studies have only begun to map. What we know is this: the anti-inflammatory action is real, measurable, and mechanistically explained. This is not folk belief. This is documented biochemistry operating in a plant that grows abundantly, costs nothing to cultivate, and requires no prescription to access. Now, here is the paradox that stops most people in their tracks. Stinging nettle contains histamine. Histamine is the compound responsible for allergic reactions, the sneezing, the runny nose, the itchy eyes of hay fever. Conventional wisdom would suggest that a plant containing histamine is the last thing you should take for allergies. Every instinct points that way. The paradox resolves like this: Urtica dioica does contain histamine, but it also contains compounds that block the enzyme responsible for releasing histamine from the body's own immune cells. It inhibits the prohistamine signaling pathway from the outside while simultaneously dampening the mast cell activity that drives the internal allergic response. The plant carries both the trigger and the brake, and in whole plant preparations, the brake wins. A double-blind, randomized study conducted at the National College of Naturopathic Medicine in Portland, Oregon, assessed freeze-dried nettle leaf against placebo in patients with allergic rhinitis, standard hay fever. Participants kept daily symptom diaries across 1 week of treatment. The results: 58% of participants rated nettle moderately or highly effective for their symptoms. In a follow-up question, the same group rated nettle more effective than the antihistamines they had previously used. The critical variable was the preparation. Fresh nettle tea showed less consistent results in this context. The freeze-dried preparation preserves the activity of the specific enzyme inhibitors that degrade quickly in heat or water. My grandmother did not have freeze-dried capsules. She harvested young spring nettles, the first 2 inches of growth, and ate them steamed, sometimes daily, throughout April and May. The timing was intuitive. Spring nettle growth coincides almost exactly with the beginning of the pollen season in Scotland. She never called it antihistamine therapy. She called it spring cleaning for the blood. The phrase sounds like old-world superstition. The biochemistry, it turns out, is surprisingly close to what she meant. The distinction between the leaf and the root of Urtica dioica matters enormously, and most people treat the plant as a single uniform thing, which is how a great deal of its medicinal value gets missed. The leaf and the root contain overlapping but significantly different chemical profiles. The leaf is rich in flavonoids, vitamins, and the anti-inflammatory lectins we discussed. The root is where the hormonal and urological research concentrates. Benign prostatic hyperplasia, BPH, the non-cancerous enlargement of the prostate gland, affects roughly half of all men by age 60. The primary symptoms are urinary, reduced flow, incomplete emptying, nighttime waking to urinate. Conventional pharmaceutical treatments work through 2 main pathways: alpha blockers that relax the smooth muscle, and 5-alpha reductase inhibitors that reduce DHT, a hormone that drives prostate tissue growth. Nettle root extract, published in the journal Planta Medica, demonstrated in a double-blind placebo-controlled trial that men taking 600 milligrams of standardized root extract daily reported an 81% improvement in urinary symptom scores over a 6-month trial period, compared to 16% in the placebo group. The mechanism involves the root's ability to bind to sex hormone-binding globulin, SHBG, which modulates the availability of both testosterone and estrogen in prostate tissue. The German Commission E, Germany's formal regulatory body for herbal medicines, which operates with considerably more rigor than its American equivalents, approved nettle root for supportive treatment of BPH symptoms in 1994. That approval has never been withdrawn. 30 years of German clinical approval for a plant growing wild in your garden. Subscribe. This kind of research deserves a wider audience. My grandfather used nettle root tea from his early 60s until he died at 89. He attributed his physical comfort to clean air and hard work. He was probably right about the air and the work. But the tea was not nothing. The inflammation story is well established. The allergy research is compelling. But the area that has most surprised researchers, and the one that will most surprise you, concerns blood sugar regulation. Type 2 diabetes affects approximately 537 million adults globally, as of the most recent International Diabetes Federation figures. Management relies on a combination of lifestyle intervention and pharmaceutical control, primarily metformin and, in later stages, injectable insulin. The pharmaceutical pipeline for type 2 diabetes is one of the largest and most lucrative in medicine. A study published in the Iranian Journal of Pharmaceutical Research assessed the effect of standardized nettle leaf extract in patients with established type 2 diabetes who were already on pharmaceutical management. The researchers measured fasting blood glucose and HbA1c, the 3-month average blood sugar marker, before and after an 8-week treatment period. The nettle group showed a mean reduction of 3.3 millimole per litre in fasting blood glucose and a statistically significant reduction in HbA1c compared to the placebo control. These are not trivial numbers in a diabetes management context. The proposed mechanism involves compounds in nettle leaf that appear to stimulate insulin secretion from pancreatic beta cells and simultaneously improve the sensitivity of peripheral cells to insulin signaling. These are the same 2 pathways targeted by some of the most commonly prescribed diabetes medications. The critical difference: nettle acts on both pathways simultaneously through multiple compounds working in concert, what researchers call a pleiotropic effect. Single-molecule pharmaceuticals typically target one pathway. The plant's complexity turns out to be a feature rather than a complication. My grandmother had no concept of blood sugar. She would not have known what HbA1c meant. But she insisted that nettle tea in the morning kept her steady. She used that exact word, steady. She lived to 91 without ever requiring medication for any metabolic condition. I'm not claiming causation. I'm noting the correlation and pointing toward the mechanism that might explain it. Long before anyone measured flavonoids or mapped NF-κB pathways, the communities across the Scottish Highlands and Ireland had a specific name for what they did with stinging nettle in early spring. They called it the spring tonic. The practice was nutritional rather than medicinal in intent, though the distinction barely mattered in practice. Winter in pre-industrial Scotland was nutritionally brutal. By February and March, stores of dried food were depleted, fresh vegetables were months away, and the population emerged from the cold months genuinely deficient in several key nutrients. The first green plant to push up through the frozen ground in meaningful quantity was stinging nettle. It grew reliably, in volume, precisely when the body needed it most. Cooked nettle leaf contains 1.64 milligrams of iron per 100 grams, comparable to spinach, but with one crucial advantage. That iron comes accompanied by its own vitamin C content, which dramatically improves iron absorption. The human body absorbs non-heme iron from plants at roughly 5 to 12% efficiency. In the presence of vitamin C, that figure climbs to 20% or above. Stinging nettle delivers both compounds in a single preparation. The traditional spring tonic was not one thing. Different families prepared it differently. Some as soup, some as tea, some as a cooked green alongside whatever protein was available. In my family, my grandmother made what she called nettle broth. Young spring shoots simmered with onion and oatmeal, served with bread. It tasted green and slightly mineral. She served it 3 times a week from March until the nettle shoots became too tough and fibrous, usually mid-May. What the tradition encoded, without knowing the chemistry, was this: eat the plant when it is young, eat it regularly. Eat it in the weeks when your body is most depleted. The timing, the frequency, and the form of preparation all turn out to optimize the nutritional delivery. Generations of observation produced a protocol that modern nutritional analysis largely validates. That is not coincidence. That is the accumulated intelligence of people paying close attention to what kept them healthy. If you do not already have stinging nettle in your garden, which frankly would surprise me, here is how to establish it deliberately and manage it productively. Stinging nettle is extraordinarily easy to grow. It is, in fact, difficult to prevent from growing once established, which is why most gardeners treat it as a problem. The cultivation challenge is not coaxing it into life. It is containing it and directing it so it produces what you want. Starting from seed or root division. Nettle seed germinates readily in spring or early autumn. Scatter seed over prepared soil, press lightly, and keep moist. Germination occurs within 10 to 14 days at soil temperatures above 10 degrees Celsius. Alternatively, if a neighbor has an established patch, and most do, a small clump of root division transplanted in early spring will establish itself within one season with almost no effort. Soil requirements. Stinging nettle prefers a soil pH between 6.0 and 7.0, which covers the range of most garden soils. The single most important factor is nitrogen. Nettles thrive on nitrogen-rich soil, near compost heaps, along fence lines where animal manure has historically accumulated, or in raised beds amended with good compost. They tolerate partial shade well, making them ideal for the north-facing corners of a garden that struggle to support other crops. Spacing and containment. Plant them roughly 30 centimeters apart. Establish a physical barrier, a buried slate edge, or a root barrier membrane, around the patch if you want to prevent them spreading. Without containment, a mature nettle patch will colonize 3 times its original area within 3 years. The third year produces the most robust harvest. A well-managed 2 square meter patch will yield enough fresh growth in spring for daily harvesting across the entire season, more than most families can realistically use. Harvest always with gloves. Take only the top 5 to 8 centimeters of growth, the first 2 sets of leaves. Cut back to the ground in late autumn. The root system overwinters reliably in all but the harshest conditions, and new growth appears in March without any intervention on your part. The plant does the work. Your only job is knowing when to pick. Knowledge without application is incomplete. Here is what the evidence supports, practically, and where the cautions genuinely matter. For leaf preparations, tea and food use. The standard therapeutic range studied in most clinical contexts is between 4 and 6 grams of dried leaf per day, or the equivalent in fresh leaf, roughly 3 to 4 times that weight before drying. For tea, steep 1 rounded teaspoon of dried leaf in 200 ml of freshly boiled water for 10 minutes, covered. Covering matters. Several of the volatile compounds dissipate into the air without it. Strain and drink. 2 cups daily covers the standard dose. For cooking, blanching fresh nettle in boiling water for 60 to 90 seconds destroys the trichomes completely, rendering the plant entirely safe to handle and eat. Blanched nettle behaves like cooked spinach in texture and takes on a clean, slightly mineral flavor. Use it anywhere you would use spinach. In soups, in pastry fillings, stirred into scrambled eggs, added to risotto. My grandmother's nettle broth recipe uses nothing more complicated than onion, oats, butter, and the fresh spring growth, simmered for 20 minutes. For root preparations, prostate and hormonal applications. The clinically studied dose is standardized to 600 milligrams of root extract daily. This is difficult to replicate with home preparations to a consistent standard. Commercial standardized capsules are the most reliable vehicle for this specific application. Freeze-dried leaf for allergy applications. As established in the Portland study, freeze-drying preserves the enzyme inhibitors responsible for the antihistamine effect. The typical studied dose is 300 milligrams of freeze-dried leaf, taken at the onset of allergy symptoms. Safety considerations that genuinely matter. People taking blood thinners such as warfarin should use caution. Stinging nettle's high vitamin K content can interfere with anticoagulant therapy. People with kidney disease should avoid high-dose preparations. Pregnant women should not use nettle in therapeutic doses, as some compounds have historically been associated with uterine stimulation. If you take any prescription medication, speak with a pharmacist before adding any regular herbal supplement to your routine. This is not a disclaimer added for legal reasons. It is accurate, practical guidance. The plant is safe for the vast majority of healthy adults in normal dietary quantities. The precautions apply to therapeutic doses, which are higher and more concentrated than simply adding nettle to your spring soup. We have covered a great deal of ground: anti-inflammatory biochemistry, clinical trials on allergies, prostate function, blood sugar regulation, iron bioavailability, cultivation protocols, preparation methods, safety parameters. But I want to return to the larger question, the one I asked at the beginning. Why does this plant remain invisible to the people who need it most, despite everything the research shows? The answer is not that the knowledge is hidden. The answer is that the knowledge was always in the garden, and we stopped looking at the garden as a source of information. 3 generations of increasingly indoor, increasingly pharmaceutical, increasingly convenience-oriented healthcare have trained people to look for medicine in a bottle, on a shelf, behind a counter. The garden became ornament. The plants became weeds. The knowledge that had been transmitted person to person for 6,000 years stopped transmitting, not because it became false, but because the channels that carried it were abandoned. My grandmother did not read clinical journals. She read the season. She watched which plants came first after winter. She noticed which members of her community stayed well and which did not, and she paid attention to what the healthy ones did differently. She was practicing a form of longitudinal observation that preceded the randomized controlled trial by several millennia. And she was not wrong about the nettle. The 200-plus studies are not revealing something new. They are confirming something old in the language that the modern world accepts as credible. The plant has not changed. Our ability to explain it has caught up. There are 537 million adults currently living with type 2 diabetes, hundreds of millions more with chronic inflammatory conditions. A significant proportion of them have stinging nettle growing within 30 feet of their front door, and they do not know it. That is the gap this channel exists to close. Subscribe and carry it forward with you. Here is what strikes me after 78 years of watching this plant grow and 4 years of reading what science has confirmed about it. Stinging nettle never needed us to understand it. It grew regardless. It stung anyone who ignored it. It returned every spring without being asked. The plant did not change. Our relationship to it changed. What this entire body of research, the clinical trials, the pharmacological analyses, the 6,000 years of human record, reveals is something more significant than a list of health benefits. It reveals that there is an entire category of knowledge that does not live in institutions, does not require funding, and does not expire. It lives in gardens, in family practices, in the quiet, stubborn tradition of people who paid attention to what worked and told the next person what they had learned. The gap between what the research now confirms and what most people actually know about the plants in their own gardens is not a scientific failure. It is a cultural one. And cultural failures are the ones we are most capable of reversing. One conversation, one cup of tea, one spring harvest at a time. The next time you are in your garden and you see those serrated leaves, that square stem, those tiny hairs that catch the light, stop before you pull it. You are looking at something that fed and healed people across 300 Scottish winters. Now you know why. If these stories belong in more gardens and more conversations, subscribe to the McGregor Family Secrets and bring someone with you.